Okay, I'm going to show you how to do the Excel stuff so that you can complete your lab report. So what I've done is basically taken out all the things that are calculated on the Excel spreadsheet and just left in the things that are typed, right? So this is data you collected in lab. You looked at your standard curve. You had a certain number of micrograms of BSA in your standard. It should have been 0, 10, 20, 50, and 100 micrograms, right? Because you took, let's say, 10 microliters of your 1 microgram per microliter BSA stock, right? And so these are the absorbance values you got. So make sure you put a nice title on the top of that, because once you highlight this, and then you go in order to insert a table. Where are my graphs? Where are my graphs? Insert. Okay, so sometimes got to do a refresher, right? Here are all of my charts and things. So what I want right here is a scatter plot. And so I'm going to pick the one without any lines. Okay, so now I'm looking at here, it says absorbance at 595, but that's not really what I want my graph title to be. I want this to be BSA standard a curve. Okay, and then what you want to do is you want to add a chart element. We need axis titles. We need a primary horizontal and we need a primary vertical, right? And so we're going to have to change this, and we're going to change this to micrograms of protein. Okay, then we're going to do the same thing here, and we are going to retitle this one absorbance at 595 nanometers. Okay, so make sure that everything is labeled. And I don't really like to have all of the axis, all these axis grid lines. I just think they get kind of messy. And so I just kind of highlight them and delete them. Okay, so what you want to do is now you want to click on this series and you want to right click on it, and you're going to add a trend line. So you're going to add a linear trend line. You do not set the intercept, but you do want to display the equation, and you do want to display the R-squared value. The R-squared value is going to tell you how good your data is. The best, most perfect data would have an R-squared value of 1. So I'm not anticipating that you'll get 1. I'm anticipating you'll get something close to 1. Okay, so we'll close that. Okay, so we have everything we need for this one. So now we have our equation of our line. This is a really, really important thing. So there are 2 pieces of information you need from this equation of the line. You need M and B. M is our slope, and I'm just going to type in 0.0099, and I just got that from the formula right there. Then I'm going to type in B, which is 0.0402. Okay, now that I have them typed into the Excel spreadsheet, I can use them in formulas, which is awesome. Okay, your total volumes are going to be different than this, okay? So don't use these values, don't use these absorbance values, use your own values. So these are just some possible values that you could have, right? Now in the sheet that I gave you in the experiment that was done with this data, it was 20 microliters of the sample, but what we used in lab was 100 microliters. So what you're going to want to do is use 100 microliters. And what you can do, you see the little green square right there, and your plus sign turns from white to black. If you drag down, it'll just copy down what you have there. So then you should have gotten a absorbance value for each of your fractions. And this just tells you the total amount of protein in each of those fractions, right? So we have an absorbance value. Now we need to convert that to micrograms. Well, here we have absorbance and we're converting it to micrograms. So what we need here is a formula. So to write a formula, you put equals, and then you're going to type in what you want. But in this case, we're not going to type in numbers. We're just going to highlight squares. So what we want to do is we want to take our absorbance. I'm going to open parenthesis. I'm going to put my absorbance, and I want to take my absorbance, and then I want to subtract. So put a minus sign. B, right? This is our formula. And I'll show you in just a second. And then I want to divide by my slope, which is m. Now, here's the kicker. Your absorbance value is going to change. So if I drag this down, that'll be perfect because this little square will go down to the next one, will go down to the next one, and so on and so on. But these two squares, these two cells, I want to stay permanently. So what I'm going to do is I'm going to put a $sign in front of both the letter and the number. And what that's going to tell Excel is to hang on to that and to not change it when I drag it down. So let me show you what that is going to do, right? So now when I pull this down, magically, oh, it's so cool. It propagates your formula. But do you see how here it moved the blue box, the absorbance box, moved down to the next one because I didn't put any $signs, but the red and the purple stay the same because they each had $signs in front of both the letter and the number. So that's really, really, really important, right? But how did I get this? Absorbance minus B divided by the slope. All I did was rearrange my little formula here, right? Because Y here's absorbance, here's my slope, this is my micrograms of protein, and this is B, and so all I did was solve for X. Okay, now I want to convert from micrograms of protein, right, to a concentration. So I know in each of these I used 100 microliters, right? So I'm going to take my formula and I'm going to say, okay, here's my amount of protein, and I'm going to divide that by my sample microliters and hit enter, and then come over and drag it down, right? Now, these numbers are a little bit different because if you remember, it was really 20 microliters here instead of 200. And so that would give you different values. Hold on. So you're going to leave yours at 100 microliters, but I'm going to change these back to 20 so that our numbers will match what you were given in the handout. All right, now we have concentration. We know how many micrograms of protein per microliter we had, or it's the same unit as milligrams per milliliter, right? So now what I want to do is I want to convert this to total milligrams inside of my sample, right? So I put 100 microliters in, I know that, and I want to know how many milligrams of protein were in that 100 microliters, right? And so all I'm going to do is I'm going to take my, let me show you kind of, I'm going to handwrite it so that you can kind of see what we're trying to do here. To get milligrams of protein, we're starting out with some kind of microgram per microliter, right? And if I could move this, okay. So what we want to do is we want to say, okay, we had 100 microliters, right? So that will cancel out my microliters. Now I want to convert micrograms to milligrams. So I know I have 1,000 micrograms in 1 milligram. So my micrograms cancel and I'm left with milligrams. So what I have to do is I have to take whatever this value was here. So it'll be my concentration. I need to multiply it by 100, and then I need to divide it by 1,000. Okay. Oh, and I don't know if you can really see that because that didn't go away. Okay, so let's do that. So we're going to take our concentration. So we're going to put an equal sign and we're going to put our concentration. And then we are going to multiply that times 100. Now you need to put this in parentheses, right? Because we want that whole thing to be divided by 1,000, okay? All right, so now we're going to drag that down, okay? Now, that's great. That's how many milligrams of protein we had in 100 microliters. But you didn't just have 100 microliters, right? You had a volume inside of your sample that you poured into your graduated cylinder, right? So we want to convert that to total milligrams of our sample. So we're going to use our concentration, our milligrams per mil concentration, right? And we're going to convert that into total milligrams of protein. So we're going to take our milligrams of protein here. Ooh, put your equal sign right here. And we're going to divide that by however many milliliters we have and hit enter. Did I do that? Something's not right. Hold on. I just grabbed the wrong cell. Hold on. So just move that over. That one. Okay. So now we have this one, and I don't want to divide. What am I doing? I want to take my milligrams of protein over here, and then I am going to multiply times my volume, right? Because this was in milligrams per mil, and I want to convert that, if I can get this, convert that to total milligrams. So I'm going to multiply times my volume. Okay, that's right. So now I drag that down. Okay, drag that down, and that gives me my total milligrams of protein per milliliter in my entire sample. All right, I'm ready to go on to part two, part B, where we're looking at LDH activity. And that's why we need this total milligrams of protein, because that's how we're going to derive specific activity. So what you did in part B was you took every 15 seconds, you took a reading, an absorbance reading during that enzyme activity assay. And so what we want to do, let me get rid of this. I'll show you how we do that. What we want to do is we want to look at how much that absorbance value is changing per unit time. And our time here that we're doing is 2 minutes. Okay, so the first thing that you need to do is you need to graph this data. So we're going to highlight all of these cells, and we are going to insert another scatter plot, just like what you did before, except this time you're going to have a couple of different trend lines on here. So we're going to change this chart title, and we're going to call this one LDH activity. LDH activity. Okay. So what you want to do, see, I like to put this, I like to get rid of these. It's just too much on the graph, right? I like to move this on the side and make it kind of long like this. Just makes more sense to me, right? Okay, so we want to add in our chart elements. We need axis titles. Okay, so this one is going to be time, if I could get it, time in minutes. And this one is going to be absorbance. But this one, instead of being at 595, is at 340, because that is in M, little m. There we go. Because that is our absorbance value for NADH. Okay, just kind of spread it out a little bit. It was kind of crammed in there. Okay, so just make sure it looks nice and it doesn't look too squashed up and that kind of thing. Let me expand this out just a little bit more. Whoa, not quite that much. Y'all at home laughing, I know it. Okay, so now, and I want this to be one single. There we go. Okay, so what we want to do is we want to go in and insert a trend line for each of these data points, right? So I'm going to kind of go in order, and I want to find my first one, which was my whole cell lysate. So I'm going to look for WC was blue. So here's my whole cell lysate. I'm going to right click on it, and I'm going to add a trend line. Same thing, do everything, display equation, display R squared. Actually, for this one, you don't need R squared because it's just going to kind of gum up everything, right? So what I'm going to do is I'm going to take it and I'm going to put it next to my legend right here. So I know that this is my equation for each one, right? Okay, so then our next one is our nuclear fraction. So we're going to add a trend line. Okay, add trend line, display equation. All right. So this is my, and if you put your cursor over it, you're going to make sure that you have the right one. Okay, so then it's going to be this one, add trend line, display equation, drag it over. Go up a bit. Come on. Sometimes me and Excel, come on. Okay, it doesn't have to be perfect, but just kind of so that you know what data, what trend line belongs to which data. Okay. And I want to display my equation, and I'm just going to drag it over. And then here, add trend line. And we're going to display equation. Okay, now what I want to do is I want to get rid of these, right? I don't need that. Whoops, don't get rid of the whole thing. Okay, come on. Why does it keep doing that? Okay, this is the one I want to get rid of. There we go. That's the one I want to get rid of. That's the one I want to get rid of. Okay, and if you want to, if you decrease this little box here, it'll kind of squeeze it together a little bit more. Maybe. It's like my computer just doesn't want to listen today. I don't know why. There it goes. Okay. So we kind of have everything all together, and we know what trend line belongs to which one. So the other thing that you kind of need to notice, I don't think that this happened to anybody in our lab, but if you do end up having one like here, the 40%, here their 40% is the green. So do you see how the green was going up, going up, going up? And then we got to this point, it kind of just leveled off. And so we don't want to include that in our data. And so when you highlight that, what you can do is you can just, oops, you can highlight it. It's the green one. Maybe. There we go. You can just take this little blue box and not include those data points. And you get a new trend line, right? There we go. Now we know that we can find the slope. We know that we can determine our change in absorbance versus change in time. So now what you can do is you can just take your slope over here. Let me put this down here so it's kind of easier for us to see everything at once. Take your slopes and put them right here. That's what your slope is, your change in absorbance versus change in time. And it'll give you units of absorbance versus minutes because it was really over time in minutes. Okay, so what we want to do here is our WC 0.0537, 0.147, 0.2028.1254 and 0.0451. Okay, so now we have, I don't know why that got highlighted. Okay, so I'm gonna move this over. So that's great. Okay, so now what I need to do, I'm gonna bring all this up. Let's see if I can just bring that up. Okay, so now what we want to do is do our calculations that were inside of the questions in your lab book, right? So if you're looking for activity, right? When you're looking for activity, you want units of micromoles per minute. And that's going to give you the number of units inside of your reaction vessel. So when you're solving for this, so our relative activity, what we just do is we take our activity, so we're going to say equals, come on, equals our, I don't know why it's doing that. That's interesting. Times, we're going to multiply by our volume in the cuvette, which was 100 microliters, right? Okay, so now, and we're going to propagate all the rest of them once we do the whole cell lysate, then we'll move on and do all the others. So to find out our total units, what we're doing for total units is we're looking at our micromole per mil times our total milliliters inside of the fraction, right? So what we're going to do is we're going to take our, this one, and we're going to multiply that times, and what I've just done is pulled this so I don't have to scroll back up and down, times our total volume, right? Now, there we go. Okay. But what I should have done, I'm looking at this right now, this is not multiply, this is divide. Sorry, y'all. Okay, that looks way better. Okay, because it's per, you have to divide by milliliters, not multiply by milliliters, right? Okay, so now we have our total units, and now what we want to do is we want to find our percent recovery. So basically what you have to remember is that you're going to start out with your whole cell lysate. That's going to be 100%. So if you want your whole cell lysate to be 100%, you take however many units you have in your sample. In this case, it's going to be the whole cell lysate, divided by the whole cell lysate. So in this case, we're dividing by the same thing, but what we want is for the whole cell lysate to stay the same across the board. And so we're going to put dollar signs in front of those. And then we want to, it's a percent, so we want to multiply times 100. There we go. Okay, so we get 100%, so that's great. And now we're going to look at our protein concentration, right? And so this is our activity right here. Let's see if I can equals our activity. And we are going to take our activity and we're going to divide by our milligrams of protein in the sample. So divided by, now you got to go up and find milligrams of protein in your sample, and that's your whole cell lysate right there. So then we're going to hit enter. Okay. And I'm just jumping ahead of myself. All you need in this one, I'm sorry, all you need in this one is we're just going to pull it down. I'm not going to do anything to it yet. That's our protein concentration, right? We just pulled it. Our protein concentration right here. Okay. It should have been this one. What did I pull? Y'all. Okay. Gotta go get the right thing. Should be this one. Okay. Which I didn't. Come on. There we go. All right. Now our concentration. Thank you, Dr. B. All right. Now our specific activity. Our specific activity is going to be what I was just saying before is our activity right here. So if we do this right here, divided by our protein concentration. I was just kind of getting ahead of the game. So the only thing we're going to have to do now is pull everything across, and then we'll work on our fold purification. So all you have to do is highlight these. Watch this magic. It's awesome. Okay. So now we got to figure out why I've got a problem here. Hang on. Okay, and my problem here is that it's pulling the wrong numbers here. So we have to go in and actually go and get these. So our nuclear fraction is right here. So we're going to do equals, go get your nuclear fraction, because it wants to pull to the side. It doesn't want to pull the bottom one. So equals, and this one's going to be, come on, right here. And then our 65. It's going to be right there. Oh, that wasn't highlighted. That one. Okay, equals, and our last one right here. Okay, there we go. Now we look good. Okay, so we got our specific activity, and now we're going to look at our fold purification. So when we look at our fold purification, all we do is we look at our specific activity of our individual fractions versus the specific activity of our whole cell lysate. So this is equal to the specific activity of whatever fraction it is divided by that of our whole cell lysate. And what we're going to do is we're going to do dollar signs so that we keep that whole cell lysate the same. So this, and we, ooh, come on. Come on. This computer sometimes. All right. There we go. And so this is the fold purification that we get with each sequential step. As we are purifying our protein, we're going to increase our purification. Okay, and so the last thing is to then change us to a way that actually kind of makes a little bit more sense, right? So what we're going to do is we're going to copy this, and then we're going to paste it, but we're going to paste special, and we're going to transpose. Oh, and I forgot to say something. So when you paste special and you want to do, let's just do paste special. We're going to transpose, but we want to transpose values. We're not going to transpose all of our formulas and all that kind of stuff. We're just going to transpose what was in there. And so what you can do is you can look at this and you can compare each of your fractions. Here's my activity of my fractions. Here's my relative activity of my fractions. Here's my total units of each of my fractions and all that kind of stuff. And it just kind of helps, and it looks nicer that way, right? Okay, so that should get you through everything. So I think that's it. All right, good luck.